most common test methods engineers use in structural design is the compressive strength of concrete cylinder. This test assesses the concrete's ability to withstand the weight of a structure or building. It also determines whether a given concrete mixture will meet the needs of a specific job. In this procedure, a continuous load is applied to the specimen until failure occurs to evaluate the compressive strength. The test is conducted on a universal testing machine. The apparatus or materials needed for this test are the following: universal testing machine, cylinder mold of 150 mm diameter and 300 mm height or 100 by 200 mm, weighing balance, tampering rod, grease, masking tape, fresh concrete Class A, retainer and cap, and lastly, L-square ruler. The standard procedure is subdivided into 3 parts. First, molding specimens. Place the molding on a flat, rigid surface, free of vibration, as near as possible to store in place. Make sure to choose the proper size requirements for the cylinder mold before consolidating. Grease the sides of the mold to prevent leakage through the joints. Put a masking tape 1/3 of the size of the mold away from the base and another one of 2/3. The tapes will be used as indicators of how much fresh concrete is to be poured into the mold. Place concrete into the mold using a scoop or a trowel. Fill the cylinder according to the standard amount of layers depending on the size of the cylinder being used. Pour the first layer of concrete until the first tape into the mold. Rod 25 times in a spiral motion from the outside to the center. Tap the outside of the cylinder 10 to 15 times with the mallet. Repeat the same process for the second layer up to the second tape. Fill the concrete again by penetrating about 1 inch into the first layer. Tap the sides of the mold 10 to 15 times with a mallet. For the last layer, repeat the same process and strike off the top and smooth the surface. Let the concrete set for 24 hours. Remove the hardened concrete from the mold and place it in a container for the water bath. Make sure that the concrete is in a vertical position and fully submerged with at least 1 inch of water. Second is curing. The concrete cylinder is cast for a standard size and allowed to cure for 6 days. Take out the specimen from the curing tank. Wipe out the excess water from the surface of the specimen. Air dry for 24 hours.
Compressive test procedures. Take 2 diameter measurements of the specimen about the center of the height of the cylinder. Second, place the specimen vertically on the platform of the compression testing machine. Uniform load application and distribution are facilitated by having pad caps at the end of the cylinders. Third, tilt the spherically seated block until it is parallel to the top of the specimen. Fourth, before starting to apply the load, make sure that the loading platforms touch the top of the cylinder. Fifth, apply the load continuously and uniformly without shock at 315 kN per minute and continue the loading until the specimen fails. Lastly, record the maximum load taken. Results and discussions. The specimen was cured for 6 days, and the maximum load taken by the cylinder was 140.21 kilonewtons. To get the compressive strength, simply get the ratio of the maximum load and the cross-sectional area. The specimen's compressive strength is 7.67 megapascals, which is about 51.2% of the total strength for Class A concrete. The strength of concrete increases with age. The table above shows the strength of concrete at different ages in comparison with the strength at 28 days after casting. Now, Class A is M15 with 15 megapascal compressive strength at 28 days. According to research, concrete with age 6 ranges from 40 to 65%. Thus, the specimen passes the test with 51.2% compressive strength under the Astm C39 standard. Calculations. D, or diameter, is equal to 6 inches or 152.4 millimeters. P max, or maximum load, is equal to 140.21 kilonewtons. Thus, Fc, or the specimen's compressive strength, is equal to the maximum load all over the cross-sectional area, which is equal to 7.67 megapascals. Thus, the strength percentage is equal to 7.67 megapascals all over the original total strength for Class A, which is 15 megapascals times 100, equals to 51.2%. Observations and recommendations. It can be seen that honeycombs are present, or small, hollow spaces on the surface of the concrete. This may be due to incorrect tampering or the mixing of the concrete, and this can affect the compressive strength of the specimen. There is a possibility that the specimen failed, but due to the wide standard percentage range, it may seem that the concrete passed the test. Thus, it is recommended to further test the concrete that follows the specific curing days with known specific standards. It can be observed in the experiment that there is a wide range between the values of 40 to 60%. It is better to conduct the test with concrete with age 3 or 7 to have an accurate standard percentage for the compressive strength of concrete.